For example, 2 summation n start from 1 to infinity n plus 1 n plus. Okay, so this is what you have here. The solution, as usual, we are going to resolve the formula in front of the summation sign into partial fraction. We have 1 over n plus 1 multiplying n plus 2. You can write this as a over n plus 1 plus b over n plus 2, where a and b are constants to be determined. So 1 is equal to, will be equal to a multiplying n plus 2 plus 1. Okay. So if n is equal to -2, what is going to happen? We have 1 plus a -2 plus 2 plus b. N is what? -2, so plus 1. So 1 will be equal to, this part will go to 0. We're going to have negative b here. So b will be equal to what? -1. So b is -1. Let's check if n is equal to -1. What's going to happen? 1 will be equal to a -1 plus 2 plus b -1 plus 1. So this part will also go to what? 0. We're going to have 1 equals a multiplying +1. So a is what? 1. So we have a as 1 and b as what? -1. So our series is going to be 1 over, this is it. And we know the values for our a and b. So 1 over n plus 1 minus 1, because b is -1, n plus 2. So this becomes our series that we are going to work with. Let me make space so that we do what we do better. Right. So this is the resulting series. We have 1 over n plus 1 minus 1 over n plus 2. Okay. So we are going to write down some of the terms. When n is equal to 1, plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5. So you see the pattern. 1 over 5 minus 1 over 6 plus 1 over 6 minus 1 over 7 plus 1 over 7 minus 1 over 8 plus 1 over 8 minus 1 over 9. In that order. So like usual, we are going to write up to the last term. So plus 1, 2, 3. Plus we are going to have our last but what? Our last but 2, our last but 1, and our last term over here. And we know our last term is 1 over n plus 1 minus 1 over n plus 2. That's going to be our last but 1. We are going to have 1 over n minus 1 over n plus 1. Because we are going to subtract 1 from the last term. Here is our what? Our n, our last but 2 term. So we are going to have 1 over n minus 1 minus 1 over n. Right? Okay. So this is what we are going to have. So let's check out the terms that are going to cancel each other. Erase this part. So we have half here. No other term is going to cancel the half. But we have negative 1 over 3 and positive 1 over 3. This will also cancel this. This will cancel this. This, that. We are all going to cancel. Here, 1 over 9 is going to cancel. Negative 1 over 9 is going to be cancelled with positive 1 over 9 if we keep on writing the terms. Because the next term is going to be 1 over 9 minus 1 over 10. So that's positive 1 over 9 will cancel this negative 1 over 9. So let's come here and do our analysis here. We have n plus 2 here. The n plus 2 is not going to be cancelled by any other term. As we have our positive 1 over n plus 1 here, negative 1 over n plus 1. We have our negative 1 over n here, our positive 1 over n, and is the 1 over n minus 1 going to be cancelled out by any other term? This is another interesting question. So you can pause the video and do the analysis to see whether the 1 over n minus 1 is going to be cancelled. Now let's write the terms backward from the last but 2 term and see. We have, this is the last but 2 term, 1 over n minus 1 minus 1 over n. If we go back, we are going to have 1 over n minus 2 minus 1 over n minus 1. So of course, this is going to cancel this. When you go back, the 1 over n minus 1, this 1 over n minus 1 is going to be cancelled out by a certain term that we didn't write, but it is in the series. And to know this, you need to think of it as writing the previous term out of the current term, and you're going to see that it's going to be cancelled out. So at the end of the day, only terms that are not going to be cancelled out, only terms that are not going to be cancelled out is what? So our partial sum, if we add them, is just what? This half, and what? The last expression over there. So minus 1 over n plus 2. These are the only terms that we are going to have after doing the cancellation. Right? So we take the limit as n approaches infinity of that half minus 1 over n plus 2. As n approaches infinity, 1 over n plus 2 will approach what? 0. So at the end of the day, limit as n approaches infinity of our partial sum is going to be equal to what? Half. So since the limit as n approaches infinity of the partial sum is equal to a finite value, then the series will what? Will converge. Alright. Let's try the last example. Let's try this last example. I would like you to pause the video and try your hands on this. Test for the convergence. Summation n starts from 1 to infinity of 1 over n multiplying n plus 3. So this is the what series. You can pause the video and try your hands on it. Okay. So let's resolve the formula into partial fractions. So we have 1 over n multiplying n plus 3. We're going to have a over n plus b over n plus 3. Have this plus b. So if our n is equal to negative 3, what's going to happen? Have 1 equals A, negative 3 plus 3 plus B multiplying negative 3. We're going to have 1 equals negative 3B. B will be equal to negative 1 over what? Over 3. Alright. Let's check if n is equal to 0. We're going to have 1 equals A, 0 plus 3 plus B multiplying what? 0. So this part will go to 0. We're going to have 3A, and A is going to be what? 1 over 3. So we have our B and our A. Right. The series is going to be summation n plus 1 to infinity of our A, which is what? 1 over 3 positive all over n minus 1 over 3, that's the B, all over what? N plus 3. Okay. But don't forget that we can factorize our 1 over 3 out. Have the series in this form: 1 over n minus 1 over n plus 3. This is the series that we are going to work with. As usual, make some space and try solve it. Okay. This is the resulting series that we have after using the partial fraction resolution. 1 over a bracket 1 over n minus 1 over n plus 3. Okay. So let's start writing some of the terms. But don't forget that each term is multiplied by what? 1 over 3. So we can do factorization. The 1 over 3 will be out, and we'll be writing the term to multiply that. We are going to have our 1 over 3 here. Open a very big bracket. So the first term, when n is equal to 1, we are going to have 1 minus 1 over what? 4. Second term, we're going to have half minus 1 over 5. Third term, 1 over 3 minus 1 over 6. That's order. 1 over 4 minus 1 over 7. 1 over 5 minus 1 over 8. 1 over 6 minus 1 over 9. 1 over 7 minus 1 over 10 plus 1 over 8 minus 1 over 11. Let's keep on writing the terms, plus 1 over 9 minus 1 over 12. Okay, so let's pause here and write the last 3 terms. Okay. Here we are going to have plus 1, 2, 3. So we are going to have the last but 2 term, the last but 1, and the what? And the last term over here. Know that our last term is 1 over what? N minus 1 over n plus 3. What is going to be our last but 1? We subtract 1 from the n. So 1 over n minus 1 minus 1 over n plus 2. Our last but 2, we subtract 2 from what? The last term. So 1 over n minus 2 minus 1 over n plus 1. Okay, so this is what you are going to have writing some of the terms. But don't forget that you need to close this big bracket as 1 over 3 is multiplying everything. Okay. So having this, let's start doing our cancellation. We have 1 here. Is 1 going to be cancelled by any other term? No. What about negative 1 over 4? We have positive 1 over 4 here. Half is going to remain, right? Because there is no way that as the series keeps on going, we are going to have any negative half somewhere. So 1 over 2 will remain. What about negative 1 over 5? We have a term here that's going to cancel that. 1 over 3 is also going to remain, because as the series progresses, there is no way that you're going to have negative 1 over 3 anywhere. So 1 over 3 is going to remain here, right? So negative 1 over 6, of course, we have positive 1 over 6 here. Negative 1 over 7, of course, there is positive 1 over 7 here. Negative 1 over 8, so cancel this. Negative 1 over 9. There is going to be a time that you're going to have positive 1 over 9, because this is the what? This is the 8th term, right? Or there is even positive 1 over 9 here, so this is going to cancel this. Yes. We have negative 1 over 10. When we move to the 10th term, we are going to have positive 1 over 10, which will cancel this. This will also leave. Everything will leave except 1 half and 1 over 3 here. So for this part, the only terms that are going to be left is 1 half and 1/3. Let's look at this it from this perspective. We have negative 1 over n plus 3. The next, the term preceding that is what? Negative 1 over n plus 2. There is no way that you're going to have positive 1 over n plus 3 anywhere else. So this is going to what? This is going to remain. There is no way that you are going to have a term that is going to cancel this. But let's look at 1 over 9. If we keep on subtracting negative 1 from the what? Sorry, if we keep on subtracting 1 from the terms going backwards, you have negative n plus 3, negative 1 over n plus 2, negative 1 over n plus 1, and the next term that's going to be there is negative 1 over n, which is going to cancel this, right? Okay, let's analyze this one too. Is there going to be a term that's going to cancel negative 1 over n plus 2? Or in other words, are we going to have any positive 1 over n plus 2? This is not going to happen, because it keeps on decreasing, not increasing. So this will remain. What about 1 over n minus 1? Of course, this n minus 2, 1 over n minus 2. If you go backwards, you're going to have 1 over n minus 1, which is going to cancel this. So this will leave, right? Okay. Negative 1 over n plus 1. There is no way that we are going to have any 1 over n plus 1 term anywhere, because like I said, it keeps on what? Increasing. So that one too is going to what? Going to stay. Let's check 1 over n minus 2. This negative 1 over n plus 1, if we keep on subtracting 1 from it, we are going to have 1 over n minus 2 eventually, which is going to cancel these two, right? Okay. So for the telescoping series, before you know that some of the terms are going to cancel, you have to project into the terms that are not actually appearing, because you cannot write all of the terms. You are probably going to write some and leave some, but you have to analyze that as I am writing these terms down. If I keep writing, am I going to get a negative or the opposite value of a particular term that is going to cancel it out? You have to do that analysis. If not, then that means that term is going to what? Going to remain. Nothing is going to cancel that term out. So here we can now find out what the partial sum. Everything is going to cancel out except 1. And since we are summing, plus have to will be there. We're going to have 1 over 32. Everything else will cancel. We're going to have negative 1 over n plus 1 plus negative, not positive here. Right here. We're going to have negative 1 over n plus 2 and negative 1 over n plus 3. Don't forget that everything here is being multiplied by what? 1 over 3. This is what the value in front. Okay. Let me clear this part so that you get a working area. All right. So this is going to be the partial sum. Let me bring the 1 over 3 in front. We're going to have 1 plus half plus 1 over 3 plus, sorry, minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3. So this is what you are going to have. So let's take limit as n approaches infinity of the partial sum. As n approaches infinity of this partial sum, 1 over n plus 1, 1 over n plus 2, and 1 over n plus 3 are going to what? Go to 0. So we are going to have 1, we're going to have 1 over 3 out, 1 plus half plus 1 over 3. This is what we are going to have left. Alright, so as n approaches infinity, the partial sum, everything here is going to go to what? 0 except 1 over 1 half and 1 over 3. So if we simplify this, limit as the mistake over here. Okay, so as we simplify, limit as n approaches infinity of the partial sum is going to give us something, I think, let me use the calculator. You're going to have 11 over what? 8. Okay. And we know that 11 over 8 is a finite value. And as the partial sum becomes a finite value, when we take the limit as n approaches infinity of that, then it means that the series is what? A convergent series. Alright, so thank you for watching the video. Stay tuned for the next episode. I hope you enjoyed the video. Have a nice day.